Ladies and gentlemen, today I'd like to talk to you about the future of energy. The energy we consume every day, very often, the energy that we see around us the most is the electricity that we consume. Electricity, along with water, constitute two of the most fundamental elements that we associate with a decent standard of living. And yet, on our planet, with a population of over 6 billion people, there is still a quarter of the world's population that don't have access to electricity. So that means there are over 2 billion people that still can't turn on the light, for example. Now, as these 2 billion people strive to improve their living condition, this means that there will be an inexorable increase in the amount of electricity demanded. Now, knowing that 85% of electricity produced today uses fossil fuels, such as coal, gas or oil, that means that as the demand for electricity and electricity production increase, then CO2 emissions will also rise, which will put pressure not only on our environment, but will increase the risk of man-made climate change. At the same time, on the other side of the equation, we know that fossil fuel resources are dwindling, and therefore it is incumbent on us to prepare for the situation. We have to prepare for a world which will have less fossil fuel resources and take steps to reduce the damage that we are doing to our only planet. In the words of Ban Ki-moon, there is no plan B because there is no planet B. Given the economic and social models that we are used to today, it's highly unlikely that people will be willing to give up their cars and their high standards of living today to, even if it is to protect our planet in the long term, because whether we like it or not, our vision is very often limited to our own lifespan, or perhaps those of our children, but very rarely can we really project ourselves to protecting the planet for generations beyond our children, our grandchildren or great-grandchildren. And therefore, there are two ways we could tackle the situation today. One is to find solutions on the supply side in order to reduce pollution and CO2 emissions, and the other is to tackle the demand side. So what can we do on the supply side? Well, first of all, we can reduce the impact of the ongoing fossil fuel consumed today. One of the solutions that could be improved is carbon capture and storage technology. Knowing that 25% of CO2 emissions in the world today are produced by coal-burning power stations, technologies or highly efficient carbon capture storage technologies could therefore have a major impact on reducing global CO2 emissions. One of the technologies that is currently being researched by scientists in Cambridge, for example, is the capturing of CO2 emissions from coal-burning power plants, which are then collected and injected several miles under the Earth's surface. The second tactic or strategy that could be used to tackle the problem of CO2 emissions from the supply side is to increase our use of renewable energies. And in order for renewable energies to become a viable source of electricity, we have to improve their efficiency so that they can compete with fossil fuel prices. Now, an example of renewable energy that has been receiving a lot of press recently is wind energy. Today, only 1% of our planet's needs in electricity is produced by wind turbines. And therefore, there is vast potential for increasing the amount of electricity that we can produce using this kinetic energy. Research so far has made it possible to make land-based wind farms economically viable without subsidies, which is good news. However, the problem with land-based wind farms is that they are a blot on the landscape, and therefore the alternative solutions to having wind farms on land is to have offshore wind farms. But that raises the problem of the fact that offshore wind farms are not yet economically viable because they are so expensive to build. There's also the issue of wind supply or wind variability, which could affect the stability of electricity supply. However, researchers are looking into overcoming this problem by improving electricity storage technologies, for example, so that excess electricity that is produced when there is a lot of wind can be stored to compensate for periods where there is less wind. Then we can tackle the problem, as I said, from the demand side. As I said before, it's unrealistic for us to imagine that people are from one day to the next, even with government intervention. It would cause massive objection and demonstrations if governments tried to stop people from using their cars. And therefore, we have to perhaps take another approach to tackling this problem in order to reduce the energy that is consumed and reduce the CO2 and pollution overall. One of the approaches that is currently being researched into at the moment, and certainly adopted in certain fields, is in transport, is producing lighter weight vehicles. Lighter vehicles can reduce overall fuel consumption. So, for example, scientists in Cambridge have developed technologies which mean that the average petrol consumption of cars, the number of kilometers per gallon, the number of miles per gallon of a car can be increased. The world record, for example, that has been achieved so far is 14,000 miles per gallon. So we can see that when we look at the average miles per gallon, the average 35 miles per gallon of a car in the UK, that the potential for improving efficiency of individual cars is huge. Work is also being done in the same way for trains and aircraft. Another way of reducing pollution and CO2 emissions through transport is encouraging the shift from fossil fuel-based transport modes to electricity-powered transport modes. I think as well there's an element to do with awareness raising amongst people in order to encourage younger generations to adopt a new lifestyle. For example, teaching younger generations, and we ourselves showing the example, that less can actually be more, and that consuming is not necessarily a way of life, and that we don't necessarily need to buy a second car, but we can do very well with one car, or indeed we can learn to share cars more efficiently. Thank you very much.